In this video, we will be discussing monopolies that produce multiple products and how they profit maximize. So here we have a problem where a computer company sells two different products, processors and graphics cards, and this company currently has a monopoly on both products. Assuming joint production, how much of each product should they sell, and what price should they sell at, and what is the profit they get from producing both of these products. And we're also given a total cost function of 500 plus 60Q, and then a quantity function of quantity of the processors, and that is equal to 130 minus 3 times the price of the processors. And then we have the quantity of the graphics cards, that is equal to 95 minus 1.5 times the price of the graphics cards. So we want to profit maximize. So what we're going to do is we're going to follow the profit maximization rule of marginal revenue equals marginal cost, and we need to find our marginal revenue and our marginal cost. So first up, we can find our marginal cost, and marginal cost is found by taking the derivative of the total cost function with respect to Q. And so by taking that derivative, our marginal cost is just 60. Now, in order to find our marginal revenue, we have to go through a number of steps. So first thing to consider is we were given quantity functions, but we want them in price functions so we can get to our total revenue and then our marginal revenue. So what we need to do is for each quantity function, we need to solve for the price. So starting with the processors, we had the quantity of the processors equals 130 minus 3 times price of the processors. And we want to solve for P. So what we're going to do is we're going to add 3P to both sides, and then subtract by quantity of P from both sides. And what we get is 3 times the price of processors equals 130 minus quantity of the processors. Now if we were to divide both sides by 3, we would get a price function for processors of 43.33 minus 0.33 times quantity of processors. And so we have the price function for processors. Next up, we want to look at the quantity function for graphics cards. So we had quantity G equals 95 minus 1.5 times the price of graphics cards. And what we want to do is we want to add 1.5 times the price of graphics cards to both sides, and then subtract the quantity of graphics cards from both sides. And what we get is 1.5 times the price of graphics cards equals 95 minus quantity of graphics cards. And so if we divide both sides by 1.5, we get a price function for graphics cards of 63.33 minus 0.67 times quantity G. And now we have the price function for graphics cards. Now since we have two price functions, we want to combine them some way so we can continue forward with profit maximization. And since we're assuming joint production, that means the total quantity equals the quantity of processors equals the quantity of graphics cards. And by using this relationship, we can then combine our price functions, since we will get a total quantity, which gives us our total price, which would then give us our total revenue total. So what we can do is price of processors plus price of graphics cards equals the price total. And so we would have a price total function of price of the processors, which was 43.33 minus 0.33 times quantity P, and then plus the price of the graphics cards, which was 63.33 minus 0.67 times quantity of the graphics cards. And since quantity P and quantity G are technically equal due to joint production, we can combine these and treat them like terms. So after simplifying, we get a price total function of 106.66 minus quantity, and I'll denote this by T for total. Now next up, we want to find our total revenue. So we have our total revenue T, and total revenue is found by price times quantity. So we would have quantity times 106.66 minus quantity total. And since quantity total is equal to the other two quantities of quantity P and quantity G, and technically this Q is quantity T as well. And so we get a total revenue function of 106.66 times quantity T minus QT squared. Next up, we want to find our marginal revenue for the total. And marginal revenue is the derivative of the total revenue with respect to quantity. And so our marginal revenue is 106.66 minus 2 QT. Now that we know our marginal revenue and our marginal cost, we can follow the profit maximization rule of marginal revenue equals marginal cost. And so our marginal revenue was 106.66 minus 2 QT equals our marginal cost of 60. And so if we subtract 60 from both sides and add 2 QT to both sides, we get 46.66 equals 2 times quantity total. And what we can do is we can divide by 2, and we get a quantity total of 23.33. And since we're in joint production, we know what our quantity for processors and our quantity for graphics cards are. So we have quantity P equals quantity G, and they're both equal to 23.33. So whenever we make one processor, we make one graphics card, and in order to profit maximize, we would produce 23.33 processors and graphics cards each. Now we want to find our prices for both processors and graphics cards. So we would go back to our original price functions. So starting with the processor's price function, we have PP equals 43.33 minus 0.33, and then multiplied by our quantity, which was 23.33. And by plugging that into a calculator, we get a PP of 35.63. So for processors, we would charge $35.63. Next up, we want to look at the price for graphics cards. So we would look at the price function for that, and that price function was 63.33 minus 0.67 times quantity, which was 23.33. And by plugging that into a calculator, we get a price for the graphics cards of 47.7. So we would charge $47.70 for a graphics card. So last but not least, we want to find our profit. And since we have two different products here, we're charging two different prices, but since we're under joint production, we have only one quantity. So our profit function would be a little bit different from before, and it would be the quantity of price 1 plus price 2 times our quantity, and it can be any quantity, so I'll denote it by quantity total, and then minus our total cost. And so our profit is equal to the price of the processors, or P1, of 35.63 plus the price of the graphics cards, or P2, of 47.7 times the quantity that we found earlier of 23.33, and then minus our total cost of 500 plus 60 times the quantity of 23.33. And after plugging all this into a calculator, we get a profit of $44.29. So by producing these two products jointly, we make a profit of $44.29. And we ultimately cut down on costs by producing these two products in the same location or factory, so we don't incur more fixed cost as a result. Because if we were to look at these as two separate monopolies instead of a multi-product problem, we would get a much lower profit as well as a much higher cost when combined. So it is more efficient in certain scenarios to act as a multi-product firm instead of two separate monopolies. That will conclude this video on monopolies that produce multiple products.